So welcome back. We're going to continue exactly where we are. So now we want to write our equilibrium system. Okay, so if you recall, we will have n different equations for zero profit condition, right? N different conditions for market clearing for y, okay, and k different equations for market clearing for factors. So S equals Z, if you remember. Okay. Now we're gonna define a matrix. So this is letter gamma. Okay, so this is lowercase gamma, and this is uppercase gamma. So we define this matrix in this way. We have 1 plus tau 1, 0, dot, 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 0, 0, 1 plus tau 2, okay, 0, dot, 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 0. And at the end, we have 1 plus tau n. Okay, so on the main diagonal, we will have 1 plus the tax rates. Okay, why do we do that? Because now we're going to write our zero profit condition in this way. PVA, V, remember this? And then we have PA, right? Now we want to multiply this because this was the cost, right, with gamma. Now be careful with the dimensions again. So this was a row vector. This was also a row vector. So this was n by n, right? This was n by n, and this was 1 by n. So this part is 1 by n. This part is 1 by n. And now we must have n by n here. Okay, so this is n by n. Okay, now what happens now? I introduce through this matrix gamma the tax rates into this equation. Okay, now we also have the supply and demand, right? So if you recall, we have supply equal to consumption demand. Now consumption demand depends on product prices, factor prices, but now it depends on the transfer, right? Because firms, the consumers' income will now also depend on this. And plus, we have the intermediate input demand. So it was like this, right? Let me check. Yes. So then, so this was the blue one was, let's say, the first one. The black one is the second one. Okay, and again, so you must be careful with the dimensions. Again, this is n by 1, this is n by n, and this is n by 1. So this thing is n by 1. Okay, and let me use green for the third one. So we have the supply of factors, right? So supply of factors will depend on product price because this comes from the consumer decision. Factor prices, and again, consumer's income, okay? And this must be equal to the firm's demand, right? And firm's demand depend on factor prices and the output. Okay, and here we have the dimensions k by 1 and k by 1 because these are basically vectors. Okay. Now at this point, I want you to count I want you to count the unknowns and the equations. Okay? Unknowns and the equations. So again, so let me use a box here. We have prices, these are unknown. How many prices? N. We have output levels, so we have 2N, right? And we have factor prices, 2N plus K. What else is an unknown? Let's answer it. I'm asking you, what else is an unknown in this new system when we extend it with taxes? No one? There's one, let me give you a hint. There's one additional unknown variable in this system. Let me share it again. Now, government determines these tax rates, right? So these are known. These tax rates, tau 1, tau 2, tau 3, tau n. These are exogenous, so they are known. But there is one unknown in the new system. What is that? Okay, that unknown is T. Why? Because T depends on, that's the last equation of the new system. It will depend on the revenue. Okay, remember this equation? Where's that? Let me just find it. There's a problem with the whiteboard. It cannot upload right now. Okay. So there's a problem there. Forget about it. So there's this T, and this is just one new variable. Remember, this was the revenue. Revenue depends on product prices, factor prices, and how much output to produce. That revenue is going to be distributed as the transfer. So the transfer itself depends on other endogenous variables. So we have this one additional unknown and one additional equation. So our system now has 2n plus k, 2n plus k plus 1 equations and 2n plus k plus 1 unknowns, okay, or endogenous variables.
Hocam burada T exogenous olmuyor mu?
No, it will not be exogenous because taus are exogenous. These taus are tax rates. These are exogenous, but then the total tax revenue of the government will depend on how much to produce and what are the factor prices. Okay, because it is put on these taxes are put on the average cost, and as you see, average cost depends on these factor prices and total cost, so that the total revenue depends on output. So this variable, the total transfer, that is distributed to households will be determined in equilibrium, because it is a function, so it depends on how much to produce and what are the factory prices and product prices. Okay. So once again, we want to use our the earlier ideas to reduce the system. So you have this now gamma, and you have just a sec, PA, yes, PA gamma, right? So you have I P minus, sorry, you have, I got confused. So you have PI minus PA gamma equals price of value added V gamma, right? Then you have I minus A gamma. Then you multiply this with the inverse of this matrix, if it exists, of course. So this inverse, if it exists, you have that, right? So P just equals that. So this means we have now that, okay? We also have Y equals CD P omega T plus AY. So I minus AY equals CD P omega T, right? So you have inverse of this times that, Y equals the Leontief inverse times that. Okay, so you have Y equals the Leontief inverse, then the consumption demand, P omega, omega, and T. Okay, then you have S P omega, omega. So this is now Y omega, right? Then you also have T, and this must be equal to Z omega and Y omega. Okay, so this is now an equation system with K plus 1. So this is K, right? This is K equations. And you also have R, P omega, omega, Y omega equal T. All right, so this is K equations over there, and this is one equation. Okay, so your unknowns are omega 1, omega 2, dot, 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 omega K and T. Okay, so you can once again reduce your system. You can once again reduce your system sorry, in this way. And then if these functions are continuous, then you define the unit simplex. And if these inverse matrices are, if they exist, then you have the solution through Brewer's fixed point theorem. Okay. Now in the textbook, there's a numerical example. Okay. Numerical example in the textbook. In that numerical example, there will be a couple of different exercises. So one assumes that delta 1 is equal to 1, delta 2 is equal to 0. Another one assumes, of course, only with two consumers. Another one assumes delta 1 equals 0, delta 2 equal to 1, and another one assumes delta 1 and delta 2 are equal to 1/2. So in the first, so this is first experiment, this is second experiment, this is third experiment. So in the first experiment, the entire tax revenue is given to the first household. In the second experiment, conversely, the entire tax revenue is given to the second household as a transfer. And in the third experiment, it is equally distributed. Okay. And if you look at the results there, you're going to see that results are not symmetric. Okay. Why is that true? Because consumers have different utility functions. So once you change their incomes through transfers, sometimes they spend more on the one of the goods, and in the other experiment, if you give the tax revenue to other person, it spends more on the other good, for instance. And even if you equally distribute the tax revenue, there are still asymmetric effects on prices and output levels. Again, this is because consumers have different utility functions, so they obtain different marginal utilities from the consumption of different goods. Okay, so what does this tell us? That seemingly egalitarian tax schemes cannot be, and in general are not symmetric. They do not have symmetric effects. And why is that important? Remember our discussion of fair allocations. When we discuss envy-free and fair allocations, we generally assume that people have different utility functions. And if people have different utility functions, your redistribution schemes may have, even if you use symmetric tax rates and symmetric redistribution schemes, you may have different results because of different utility functions and different endowments. All right. So usually distributive policies are not neutral. So that's the main takeaway message from this exercise. Okay. So that was the simplest possible way to extend our basic model in chapter 3 with taxes and the government. Now we're going to look at different examples in the rest of today's class. But if you have some questions, I can now clarify any parts. Okay. Now we're going to introduce income taxes and factor taxes, factor income taxes, and so factor use taxes. We're gonna tax the firms when they use a particular factor, and then we're gonna tax the consumers using income taxes. Okay. So let me again share my screen. So now the average cost will look like this. for this firm, so we have VJ, right? And then we put the tax in front of here. So we're gonna use T to differentiate it from the ad valorem tax. So this is now TJ, okay? Sorry, that was a mistake. So this is now TK, because I am putting the tax on the use of the factor. So all firms will be affected by that. And this firm was using that amount. And again, we have the intermediate input cost. Okay, so that's one part, and I must be careful here with this one as well, because now, since there is this tax rate here, the optimal behavior of the firm will also depend on the tax rate. Okay, so when I write T, I basically mean a vector in this form. Okay, for each factor, there is this tax rate. So it look at what it does. It basically increases the price paid for that factor. Okay, so how could this be relevant in actual economies? Well, again, suppose that some, for instance, I want to tax robots. Okay, because if firms use robots or other machines that increases automation, that is harmful for workers, let's say, then I want to increase the tax rates on robots so that I can disincentivize the use of robots by the firms. So you can imagine other environmental issues, other redistribution issues, trade-related issues, etc. Okay, but basically the government here wants to tax these factors, the use of these factors, by increasing the cost associated with these uses. The costs basically paid by the firms. Okay. Now again, equilibrium will be requiring this, so we are not changing that part. And on the consumer side, we have something like this. So the consumer's budget constraint will look like this. We will have price and consumption. So this is again for consumer H. Okay. Now this must be equal to income. Now income will be like this. Remember, there are factors. They sell these factors. They have their endowments. Plus, they obtain the transfer income. Again, in this model, there will be transfer income. But then, the government now puts an income tax, MH, okay? There will now be income tax. So when I write M, I basically mean M1, M2, MH. From each household, we take MH of their income, okay? And we are doing that after the transfer, okay? Alternatively, we could have done that, right? We could have done, we could tax the income before distributing the tax. Okay, that would be an alternative formulation. Okay, this one. But here in this example, so this is directly from your textbook, we first distribute the transfer, as in the earlier example, and then this after transfer income is taxed at rate MH. Okay, so part of this becomes government's revenue, another part remains with the consumer, so the consumer spends it. Okay, now if you do the rest, now let me directly write the equilibrium conditions. So you have Y equals, there is now this total demand. Let me just write it in this way. So now, of course, total demand depends on both the transfer and the tax, right? And so within that, we also included the intermediate input demand. Don't maybe we should write in this way. So this is not really the good way to write it. So once again, you have that. For the zero profit condition, you have this, right? But now the price of value added will depend on T, right? Because firms will respond to the tax rates that is put on the factory use, because prices, don't forget, now the cost will be something like this, right? So this part will be affecting the price of value added because firms are doing an optimal choice. Then you have, again, this part. There's no ad valorem tax here. Then you have the supply. So supply, again, will depend on these things, right? And this demand is now depending on this T as well, by the same reasoning, because remember, BKJ depends on T as well. If taxes are larger, then the total cost paid for any factor is larger. Then you have the revenue. Again, revenue depends on many things, right? Output, T, M, and T, okay? And this will be, again, equal to the transfer. Now, how many equations, how many unknowns? Again, you should be counting that. Let me be helpful in this regard. So you have some exogenous stuff here. What are these exogenous stuff? T's, M's, right? These are exogenous. Okay? What are the endogenous variables? Your endogenous variables are, again, P, omega, Y, and T. Okay? So you have N equations here, N equations here, K equations here, and one equation here. Once again, you're going to do the math. You're going to define the Leontief inverse. You're going to express P and Y as functions of these things. And I mean, in general, more generally, they depend on T as well. Okay? Then you're going to put all these things into here, into here. Then you have this reduced system, and your unknowns are omega 1, omega k, and t. Okay? So government determines exogenous tax rates for factors and income levels, incomes of the consumers. Careful, these are for factors again, and these are for consumers. Okay? Then you have the solution concept exactly as before. Okay, again, this requires all of these functions to be continuous, this inverse to be existing, right? And you have it. So that's a slightly more complex example. If you want to get the real sense of it, you can actually solve the model from the very beginning. Okay? Remember our chapter 3 solutions? We solved each and every problem by hand. Remember, we found conditional factor demands, we find price of value added, we found BKJ, etc., etc. You can actually do that with M and T in the model. So you can actually, for instance, prove that price of value added will depend on T, consumption demand will depend on T and M, optimal factor demand will depend on T, etc. Okay? So that would be even better. So if you want an exercise, you can do it. Now let me make a quick stop here. If you have any questions, then I will continue with more content. Okay. Now, next thing we're going to do is to introduce public spending. Okay? Or government spending more generally, right? So we want to imagine something like this. So there is this revenue, right? And there is the transfer. Now, instead of giving entire tax revenue as transfer, the government can make some public expenditure. Okay, so here E will be the public expenditure. So the or the units of public good, let's say. Okay. Use of public goods, and PN will be the cost covering price of the public expenditure, cost covering price of E, let's say. Okay. So this is then the government budget constraint, right? And we assume there is a balanced budget. You can also do something like this. You say transfers are of two kinds. One depends on one is fixed, okay, fixed transfers. You always make this transfer spending, and the other depends on other stuff. For instance, it can depend on the factor prices in the economy. Let me check. Yeah, so it can depend on this stuff. So here you can give the government some flexibility in determining how to give transfers. Okay. So there could be different ways of modeling government in that context. And finally, you can actually tell me that the government can run a deficit or a surplus. Okay, D. So if you look at D, so if you rewrite D, you have revenue minus the total expenditure, right? Total expenditure is fixed transfers or autonomous transfers, non-autonomous transfers, and the expenditures on the public good. Okay. So if D is positive, it is a budget surplus, right? If D is positive, it is a surplus. If D is negative, it is a deficit. Okay. Now we're going to continue in the third hour with the government example. And we're going to continue with savings and investment. Now let me stop sharing. So we have less than a minute. It's 1:35. So let's meet at 1:50. Okay.
Okay.
And at the beginning of the third hour, I will explain. I will answer your questions if you have any. Okay.
Okay.
All right. 1:50.